I like to do a normal probability plot on one of these categories. I'm going to choose peak heart rate right here. So what I'm going to do is I'm going to grab this entire data set, and I can see there's above 558 values. I'm going to actually create another blank sheet here by pressing this plus button. I'm going to right click and copy, and I'm going to paste the data set right here. Okay, so the first thing we need to do is the data set needs to be ordered in order to do a normal probability plot. So I'm going to go to the right here and do a sort from smallest to largest. And now my data set has been ordered. So this is very important. This will not work otherwise. The next thing I'm going to do is I'm going to come over here and just enumerate the data set. So for example, this is data value number 1. This is data value number 2. Now of course there are 500 values. I am not going to continue doing 3, 4, 5 all to 500. What I'm going to do is I'm going to highlight these two values that I typed, 1 and 2. Go to the right hand corner of this rectangle until my mouse button turns into this black cross. Hold down my mouse button and drag, and then the Excel will do all the enumerating for us. So there's 558 values. Okay, now I'm going to go back to the top here, and what I'm going to do right here is I'm going to write expected Z, and that's going to be my expected Z-score. And in order to do this, I'm going to type the following. I'm going to give myself a little more room here so you can see what I'm typing. Type equal to norm SINV, then I'm going to parentheses one more time, and then I'm going to click here to the enumeration, which is B1 minus 3/8. 3/8 is a constant, so no matter what I'm doing, no matter what the data set, I'm always going to type minus 3/8, close parentheses, so this sits in the numerator, divide by the sample size plus a quarter. So in this case, my sample size, if I go down here, I can see was 558. So my sample size is 558, the last data value there. And I'm going to add a quarter, so 558.25, and close it. This will give me my expected z-score. Again, the quarter is just a constant I'm adding. So my only variables are really the enumeration and the sample size here. You'll notice that in order to find the expected z-score, I'm not using the actual data value. This is my expectation. So really all that's happening is if you were to grab 558 values from a normal distribution, what would I expect the values to be in terms of z-scores? So now I'm going to hit enter, and so it wants to say that I should get a z-score of negative 0.30565, so on and so on and so on. That's what I'm expecting. So now we're going to go what I expect against what I really got. I could also find the z-score here as well, but I'm not going to. Some programs do that. They do the expected and this actual. So I'm now going to go again to the lower right hand corner. Once I select this, drag down while I'm holding the mouse button, and now I will find all the z-scores, expected z-scores. And again, you notice that that ends with the same number I started with. One's positive, one's negative. Again, this thing is symmetrical. So again, to make all those happen, I clicked on the rectangle that I typed originally, one to the lower right hand corner and drag down to create the rest of the values. And now I'm just ready to create my graph. I'll highlight both columns, my expected z-score and my data. Go to insert here, and I'm going to select this graph right here, which is insert scatter XY. Again, I'm going to choose a scatter plot. So all we're going to do is graph all the ordered pairs. Again, you have choices. I'm going to select the first one, the one that does not connect. You don't want to connect these with lines. You don't want to smooth it out. You just want the ordered pairs to appear. And there is my normal probability plot. You can see that it's fairly straight. Again, my technique is just to go from -1 to 1, create like a straight line using that, and then extend it out. So it looks something like this. Let me go back to insert. And I want to insert a picture. Here's a little icon for shapes. And I'm going to select a little straight line here. And again, what I do is just kind of eyeball it from 1 to -1, and that looks about right, and then I just extend it, trying to just continue looking at 1 to -1. I'm also going to change it to a different color so I can see what I'm doing. There's a couple ways of doing this. I could right click and format object, and when I do this I can select the color. So I'm going to go red so it stands out, and the width of this line I'm going to make a little more bolded so it really stands out. Okay, that's good. And then I'm going to just extend this line. Again, I'm just kind of eyeballing this thing, but I'm keeping my eye on 1 and -1, trying to just thread it through those values. And again, you can see that the data set is fairly straight. Sure, there's this one value that's jumped up, but that's one value. Like, these are the extreme values. Notice it's 3 standard deviations away. So these are harder to predict. So seeing one jump like that is not a unusual thing to happen. Since across the entire graph this is fairly straight, my conclusion is that yes, indeed, in this case, this is peak heart rate is for this study was normally distributed.